Now that we've seen how the algorithm can be simulated, let's take a look at the actual code for it. So here the code is reasonably simple. It's actually even simpler than selection sort. So yeah, here we have our bottom two helpers. We'll just kind of ignore those. We've already talked about them. Looking at the code, we got two loops again. Typically when you have sorting, you're going to see two loops. So looking here, we have our first loop, I equals 1 to n. So this runs n times, right? This is pretty straightforward. Somehow right there's kind of a mental note there that I can start at 1. Because so we have this idea, right? I have my basically my array split into two different pieces, right? One is basically sorted, unsorted. So no elements is sorted. One element is also sorted. So if I want to pick that region in front to start with, that sorted region I'm adding things into, it's actually for a game for me to pick it to have one thing. So when I start at I equal 1, I'm basically saying that whatever's at index 0, I'm going to assume that's the sorted region. It's good to go. I don't need to do anything to it. So that's actually just fine there. If we started at 0, it would work out as well, but we do more of the work than we need to. This is kind of the most performant thing. All right, so we have our outer loop. It's going to go and look at each element one at a time and then take that element and shift it into the position that it belongs. All right, so look at the inner loop. The inner loop has basically, well, it has an exchange in there and then it has a really complicated loop conditional. So I have my for loop. My for loop is supposed to be looping over something called j, right? So j is basically j is sort of like my it's basically me walking the data, right, and trying to shift something to where it belongs. Okay, so initially I say, oh, I'm starting at I, because that's the thing that I'm looking at. It's the thing I want to put in the proper position. And what I want to do is I basically want to compare that, right? I want to compare j, right, which initially starts with the first element I'm looking at, with what comes before it, right? So I want to know, is I and the thing before I, right? So if I'm looking, here, I got to compare, I with I minus 1. J is because we need to move throughout it, right? Here it's just one position, but if I start over here, right, I would have to walk this way. So J changes as you walk to the left. All right, so J has basically two conditionals, right, as it's looping, right? Notice the looping here is down, right? So we're pushing things to the left. Start I, push to the left. Two conditionals are basically A, is it out of order, right? So I only need to swap two things when they're out of order, right? So is it not the case, right, that well, it is the case, right? We're fine when it's basically j is less than j minus 1, right? So when they're locally in order, right? When they're locally out of order, then we loop, right? Once that's false, once it is in order, then we drop out of the loop, then we're done. So that's one condition, right? Are we in order or not? And then the second condition is are we in the array or not? Because we don't want to try comparing ourselves with something outside the array. So we just make sure we're inside. And we have to do that, right, because we're doing this j minus minus. Otherwise we have, typically, right, we have things like I less than n to stop us from going outside the right-hand side. Here we're doing, while j is greater than 0, basically say, well, we're, inside the array. While we're slightly inside the array. So greater than 0 means that j has to be at least 1. So it's like get almost to the edge. We're not even allowed to get to the edge, and you'll see why in a second. So yeah, this inner loop basically runs. It keeps on comparing things, and it's designed to basically make that swap while we're inside the array and while we're out of order. The exchange here is between j and j minus 1. So it's like the thing we're looking at and the thing that comes before it. That's why we don't want j to become equal to 0. That's why the smallest it can be is 1, because we're going to swap j with j minus 1, right? And if we let j go down to 0, well, then we'll be swapping 0 with minus 1, right? So that'll blow up. So yeah, that loop just runs a whole bunch of times, right? And it'll run, right, until we get to the proper position. If it happens to be the case that we, looking at an element and it is actually in proper order with what's next to it, we just leave it alone. Done deal, right? Nothing to do. If it's at the far end, this will run a whole bunch of times. So this loop, right, is kind of very much dependent on how the data is laid out. All right, so this is an example of some source code to implement this algorithm. Again, it's always going to be something that I recommend you put an ID, try playing with it, try running, seeing what results you get back from it.